We're the Borderland Steel Team from the University of Texas at El Paso, working out of the Keck Center for 3D innovation. We created this video as part of our submission to the Additive in Steel competition by America Makes. The mission is to design and build a multi-tool using additive manufacturing technologies. In addition to the tools requested by America Makes, we also took time to conduct a few interviews. Talking directly with multi-tool users gave us a clearer understanding of real needs.
What is the most important aspect of a multi-tool for you?
It's got everything you need in a day. Pliers, cutters, whatever. Got everything.
As someone who uses a multi-tool very frequently, what are some tools you would like to have always?
These are the kind of tools that I carry on me basically every day, given the variety of machines that I need to fix. And so having the ability to work with plumbing parts, cut wires and zip ties, that kind of thing, light up my work area. Having all that included, I think will help a lot as far as actual usability.
As a mechanical engineer, what tools do you use on a everyday?
So a Phillips head screwdriver, a flathead, 10 millimeter socket or wrench, and Allen keys. And pliers.
Across user interviews, the same three conclusions emerged: versatility, adjustability, and ease of use. To guide our design, we also benchmarked commercial multi-tools across multiple materials and use cases. We used X-ray computed tomography to capture the internal geometry and mechanism details. Following benchmarking, we ran a concept exploration in which every student developed a sketch for a multi-tool concept. The goal was to generate a wide range of ideas quickly, including bold and unconventional concepts, before narrowing in on the best architecture. Printing in PLA on desktop printers gave us a hands-on way to evaluate our ideas. From there, we organized the recurring designs and chose the direction that best matched the requirements. As the design evolved, our mentor Dr. Medina helped guide our refinements with decades of experience in additive manufacturing. Beyond the defined requirements, we added creative features that improve real-world utility in both the lab and field. Light, useful when visibility is limited. Bit module, quick access to common drivers. Pen, quick notes while you work. We followed design for additive manufacturing strategies, including part consolidation and light weighting. In our design, we reduced the part count from roughly 20 parts to about 5 by consolidating features and standardizing interfaces. We integrated lattice structures to reduce mass while maintaining strength in critical load paths. After refining the design, we printed resin iterations to capture tighter details, better surface finish, and more realistic fit. With each iteration, we improved tolerances and movement, refined ergonomics, and made the mechanism more reliable. For the metal build, we're using 316L stainless steel with LPBF on an EOS platform. Holes and internal features present an LPBF challenge, as downskin can leave downward-facing surfaces rougher and undersized. To address that, we designed build-friendly hole geometries with 45-degree internal transitions and multiple diameter variants, then tested to see which configuration produced the best fit. Some test samples did not achieve free movement and also failed under load, so we carried out additional analysis to understand the fracture mechanisms. After applying improvements to the design, we printed the first version in metal, but the build failed midway because of a recoder issue. We made a few process configuration adjustments, printed again, and this time it worked. Once the parts were removed from the printer, they were taken to a wire EDM machine to be cut from the plate. After that, we finished the post-processing by removing supports and sandblasting, preparing all the parts for assembly. Once the assembly was complete, we tested the multi-tool for all key functionalities: hammering, glass breaking, Phillips No. 2, flathead, Allen wrench, prying tool, 1/4 inch socket, seatbelt cutting, pliers, and wire cutters. We also tried a few additional features, including the light and pen. With these functionalities, we aim to meet the contest requirements while also delivering versatility, adjustability, and ease of use. We are grateful for the opportunity to take part in this challenge, and we wish all teams a great contest.